Hey everyone, and welcome back. This time we're diving into photonic chips, specifically this new TaiChi chip that's making some pretty big claims.
Yeah, this chip is really making waves.
I bet. So to start off, can you give us a quick rundown on what exactly a photonic chip is? Like, I get that it uses light, but how does that actually work?
So it all boils down to photons. Yeah,
Photons.
you see, light is made up of these tiny little packets of energy called photons. And unlike the electrons that regular chips use, photonic chips use these photons to transmit and process information.
Huh. So instead of electrical signals, it's like light signals zipping around.
Exactly. And because photons travel at the speed of light, well, that means computations can happen incredibly fast.
Okay, wait, hold on. At the speed of light, like no lag time whatsoever.
Pretty much. It's mind-bogglingly faster than traditional electronics.
I can only imagine. But how did we even get to this point? Like, where did this whole photonic computing thing even begin?
It's a fascinating journey that starts with the invention of the laser back in the 1960s.
Ah, the laser. That seems like ages ago.
It was a game changer. Lasers gave us this ability to create a really focused, intense beam of light, and that was crucial for controlling photons, which is kind of essential if you want to use them for computation.
So the laser was like the first step towards harnessing the power of light for computing.
Precisely. Then came optical fibers.
Right, those things that carry data as light pulses over long distances.
Exactly. That was another huge breakthrough. Suddenly, we could transmit information at the speed of light over vast distances.
So we have lasers to create light and fiber optics to transmit it. What was the missing piece of the puzzle?
Merging that speed with the manufacturing capabilities of electronics, enter silicon photonics.
Silicon photonics. So that's like using silicon, which is the backbone of electronics, to manipulate light instead.
You got it. It was a brilliant fusion of technologies, but of course it wasn't without its challenges.
Yeah, I was about to ask, didn't previous photonic chips have some limitations?
They did. And that's where this new Taiji chip comes in with a really innovative approach. It all comes down to how it manipulates light using two key concepts, interference and diffraction.
Okay, interference, I remember that from our deep dive on waves. It's like how waves can either amplify or cancel each other out, right?
Right. And photonic chips use this phenomenon to create logic gates, which are like the fundamental building blocks of computation.
So they're kind of like the transistors in electronic chips.
Exactly. And they work by manipulating the intensity of light to perform logical operations.
Interesting. So playing with the brightness of light is like flipping those ones and O's.
You got it. Now, diffraction is a bit different. Imagine shining a flashlight through a narrow slit.
I think I've done that before.
Instead of a sharp line of light, you see a wider, more diffused pattern. That's because the light bends and spreads out as it passes through the opening. It diffracts.
Okay, I can picture that. So how does diffraction play into computation?
Well, you can encode data into the properties of light and then pass it through layers that diffract the light in specific ways. Each layer acts like a mini pre-programmed circuit, performing a specific operation based on how it diffracts the light.
So it's kind of like a mini circuit board hardwired for a certain function.
Exactly. But the problem was these diffractive operations were fixed. They couldn't be easily reconfigured, and that lack of flexibility was a major hurdle for photonic chips.
Okay, I see where you're going with this. So this is where the TaiChi chip comes in and shakes things up.
You got it. The TaiChi chip cleverly combines both diffraction and interference to create a system that is both fast and flexible.
Wait, so it uses both. How does that even work?
Picture this. First, data is encoded as specific optical patterns using diffraction. Then these patterns enter a device called a Mach-Sender interferometer, which uses interference to manipulate the light beams. This interferometer performs complex calculations. Finally, the output is decoded, using another diffraction layer.
Wow, so it's like a carefully choreographed dance of light with diffraction setting the stage and interference making the magic happen.
That's a great way to put it. And because photonic computing can perform many operations simultaneously, it blows traditional computing out of the water in terms of speed.
So instead of processing things one step at a time, it's like a whole orchestra playing in harmony.
Precisely. But speed isn't the only advantage. The TaiChi chip also boasts some impressive stats when it comes to complexity and accuracy.
Okay, I'm all ears. Tell me more.
This chip can handle a mind-blowing 14 million parameters.
14 million. Whoa. But what does that even mean, handling parameters?
Good question. Parameters are essentially the variables that control the complexity of an AI model. So the more parameters, the more sophisticated the AI can be. And 14 million is a huge leap forward for photonic computing.
Okay, so more parameters, more brain power. Got it. But how does it actually perform? Like, can it compete with traditional chips in terms of getting things right?
Absolutely. In tests, it achieved 92% accuracy on image classification tasks.
92%. That's amazing. Especially for analog computing, which I always thought was less precise than digital.
That's a big deal. And it doesn't stop there. It's also incredibly energy efficient. We're talking over 1,000 times more efficient than even the most advanced GPUs out there?
Hold on, so it's faster, more accurate, and uses way less energy? That's incredible. Does this mean we'll be seeing photonic chips in our phones and laptops anytime soon?
Well, not so fast. There's still some challenges to overcome. For one, the current system still relies on external lasers, which makes the whole setup quite bulky.
Ah, so miniaturization is the next hurdle.
Exactly. And right now, this chip is mainly designed for what we call inference, that is using existing AI models to process information, not training new ones.
So it's more about applying what it knows than learning new things.
That's a good way to put it. But even with those limitations, this chip is a major breakthrough. It offers a glimpse into a future where photonics could revolutionize computing, particularly in AI.
This is seriously mind-blowing stuff. We've covered so much already, from the basics of light to the inner workings of this incredible chip. I think we need to take a break here, let all this information sink in.
You know, it's really amazing when you think about it. It's not just about speed or efficiency with this chip. It's about doing things we couldn't even dream of with normal electronics.
Ooh, that sounds intriguing. Like, what kind of things are we talking about?
Imagine a world where your devices are processing information at the speed of light. You could analyze huge amounts of data in real time, stuff like medical imaging or financial markets. It'd be incredible.
I see what you mean. It's not just about making our phones a little bit faster. It's like opening up a whole new world of possibilities in tons of fields.
Exactly. And the TaiChi chip is a big step towards making that a reality. One thing the research really highlighted was its potential for generative AI.
Generative AI, oh yeah, that's the stuff that can create art and music and even write stories, right? Everyone's talking about it these days.
That's right. And the researchers actually showed that the chip can do that. They used it to generate music in the style of Bach.
Wait, a photonic chip composing music? That's wild. Did they actually, like, release any of the music it created? I'd love to hear that.
Well, the paper didn't include any audio samples, unfortunately, but they did say that the chip managed to capture some of the key elements of Bach's style.
Still, that's pretty amazing. And it wasn't just music, right? I think I read something about it creating artwork, too.
Yep, they used the TaiChi chip to generate landscape images as well. They even managed to mimic the styles of Van Gogh and Munch.
So this chip is like channeling the artistic spirit of the great masters. That's kind of freaky, but also really cool.
It definitely raises some interesting questions. But putting that aside for now, the practical applications are huge. Imagine what this could mean for artists, designers, musicians. They could work with AI in ways we've never even thought of before.
Yeah, I can see a whole new world of creative possibilities opening up. But what about applications beyond art? Where else could this generative AI stuff make a real difference?
Think about fields like drug discovery or material science. Imagine using AI to come up with new medications or materials that are lighter and stronger than anything we have now.
Now, that would be a total game changer. Having AI design life-saving treatments or revolutionize entire industries with new materials, that's amazing.
And don't forget with the energy savings, this chip is over 1,000 times more energy efficient than current GPUs. So it could have a huge impact on reducing carbon emissions and fighting climate change.
Right, so it's faster, more powerful, and better for the environment. It's like a win-win-win situation. But you mentioned earlier that there are still some limitations, right? What are the main things holding this technology back from going mainstream?
Miniaturization is still a big challenge. Like we talked about, the current system is pretty bulky because it needs those external lasers. And right now, it's mostly focused on inference using existing AI models instead of training new ones.
So it's really good at using what it knows, but not so good at learning new things yet.
Yeah, that's a good way to put it. But even with those limitations, this is still a huge accomplishment. It gives us a glimpse of a future where photonics could completely change the world of computing.
It's amazing to see how far we've come and to think about all the potential that's still out there. What are some of the other areas where you think photonic computing could have a big impact in the future?
One area that's particularly exciting is quantum computing. Like I mentioned briefly earlier, photonics could potentially make quantum computing possible at room temperature, which would be revolutionary.
Quantum computing, that always sounded like something straight out of Star Trek to me. But if photonics can make it more practical and accessible, that would be mind-blowing.
Think about it. We could solve problems that are currently impossible even for the most powerful supercomputers. Stuff like drug discovery materials, science, even breaking encryption codes.
Whoa, this is getting pretty intense. It's definitely making me think about the future in a whole new way.
And remember, this is just the beginning. We're still in the early stages of exploring the full potential of photonic computing. Who knows what incredible breakthroughs are just around the corner?
I can't wait to see what the future holds. But for now, I think we need to take another break and let all of this sink in. We'll be back soon with the final part of our deep dive, so don't go anywhere. Welcome back, everyone. I gotta say, I'm still kind of reeling from all this talk about photonic computing. It's amazing to think that we might be on the edge of like a whole new era of computing.
Yeah, it really is an exciting time. And the thing is, we've only just begun to explore what's possible with this technology.
Right, but before we get too caught up in all the cool stuff, it's probably a good idea to step back and think about the bigger picture. Like, what does all of this mean for us? What are the implications of a technology this powerful for society as a whole?
That's such an important question. I mean, like any transformative technology, photonic computing, comes with potential benefits and potential challenges.
Right, it's not all sunshiny rainbows. What are some of the potential risks or downsides that we should be thinking about?
Well, one thing that comes up a lot is the impact on jobs. As AI gets more and more sophisticated and starts being used in more industries, there's a concern that it could lead to job displacement.
That's a legitimate concern. It's happened before with new technologies, right? Some jobs change, some disappear. But how do we make sure that the benefits of this technology are spread evenly and that everyone benefits, not just a select few?
It's all about being proactive and thinking ahead. We need to focus on things like education and retraining programs to help people get ready for the jobs of the future. We also need to create policies that make sure the transition is fair and equitable so everyone has a chance to benefit.
I agree. It's not about stopping progress. It's about making sure that progress works for everyone. Are there any other potential downsides that we should be keeping an eye on?
Access to the technology is another big one. We have to be careful about the digital divide and make sure that photonic computing doesn't make existing inequalities worse. If this technology is only available to certain groups or regions, it could create even bigger gaps in opportunity and resources.
Yeah, that makes sense. We need to make sure that this technology is developed and used in a way that's inclusive and benefits all of humanity. So how do we actually do that? What steps can we take to make sure that photonic computing is used responsibly and ethically?
It may take a team effort. We need policymakers, researchers, industry leaders, and even everyday people to have open and honest conversations about the potential impacts of this technology. It's about coming up with guidelines and regulations that prioritize things like ethical considerations, sustainability, and equal access.
I like that. A shared vision for the future. It's not about one group telling everyone else how this technology should be used. It's about working together to create a plan for responsible innovation.
Exactly. And it's not just about rules either. It's about creating a culture of responsibility within the tech industry. We need to encourage critical thinking, ethical decision-making, and a commitment to using technology for good.
Well said. It sounds like there's a lot to think about, but also a lot of potential for positive change. It's kind of both exciting and a little scary, don't you think?
I agree. It's both a challenge and an incredible opportunity. We're at a really important point in the evolution of computing, and the choices we make now will have a huge impact on the future. But, I'm optimistic. I believe that if we approach this technology with wisdom and foresight and a real commitment to the common good, we can harness its power to create a better world.
I'm with you on that. Well, on that note, I think it's time to wrap up our deep dive into the world of photonic computing. We've learned about the basics of light, the amazing advancements of the TaiChi chip, and the broader impact this technology could have on society.
It's been quite a journey.
It has. And for our listeners out there, I want to leave you with this thought. As photonic computing continues to evolve, it's going to affect every aspect of our lives in ways we can barely imagine. So stay curious, stay informed, and stay involved in the conversation about how we shape the future of technology.
Remember, the future isn't something that just happens to us. It's something we build together.
That's a perfect way to put it. Thanks for joining us, and until next time, keep exploring, keep asking questions, and keep diving.